The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spend a lot of time making sure the accurate information gets out.
This is live. There's still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, the group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I am geologist Philip Ong here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Kilauea volcano update. Today, Thursday, October 7th, 2021. You guys are looking at a view of a video I took just this morning from the Kanakakoi overlook in Hawaii Volcanoes National Park of the visible vent erupting lava here. our current eruption. And we're gonna spend some time today telling you guys about what's happening as far as the new signals on the volcano, the new developments. The biggest thing that seems to be happening right now is some changing on the surface of the lava lake. It seems like that old crust might be rising up through that liquid and it's displacing it perhaps. It looks like the liquid is stagnating, like the crust is rising and maybe all crusting over all that stuff, like some balance of all those things happening. So we'll check that out when the time lapse is here. We will be taking questions as we go, so pass them on to Dane and drop them in the chat. I'll try to keep an eye as much as I can. Dane will collect the ones that I can't notice or that he can't answer by text here, and we'll discuss them at a midway break in our presentation here. And also let Dane know if you have any issues with our video or audio. He'll be monitoring the streams here as well. So mahalo, Dane, for taking care of all that stuff. I say it every time. It's a huge amount of work every time, and just making sure everyone realizes. Yep. All right, so here is our newest view that we can see from the public. We have some other USGS views we're going to share today, all the photographs, all the video, and all the signals. But I thought since this is really a more of a personal experience here with you guys, trying to connect with what you might be able to see yourself by going to Hawaii Volcanoes National Park, I thought it was important to show this view as well, which is something that the USGS is obviously not going to put out. So there's that. We'll come back and show you a little bit more of that later. But that's the video this morning. That's released as a short as well with our rainbow video that I put out earlier today. So check that out. All kinds of video coming to you guys today, including an extra drones on. You guys have been waiting. It's coming after our broadcast tonight, so stay tuned for that. All right, so this is a video that was released on Monday, I believe, but it goes back to the weekend, and it shows. I might pause it and go back here. It shows this configuration of the lava lake with this active west vent down here in the bottom right of the screen, and that southern vent at the middle part here. Let's see if I can get my Madden pen to work. And it is right there. So okay, there's our west vent. I've been calling it New West, or New West vent, because our old west vent has become a bit of an island over here, a big mass in the lake. We'll talk about that later. But also our southern vent that's over here. You can see it bubbling a little bit. It's pretty small in this view. Maybe you can barely see it on your screens, depending on what kind of screen you're looking at. But I'll highlight it again right there. That's that southern one. And if I scroll over here, this is that new west vent over here. Old west, this kind of darker blob, which is be more evident in other photographs here. So I'll play it here, you guys. It'll cycle through the different views. First of the west vent, close up, and so what you can see what's happening there from we can't see from the park perspective is there's this lava channel that's draining the vent here on this downhill side. Well, I say downhill, but on the lava lake side. The lava lake has been rising, and it's currently now at the level of this gap here. So this is essentially just connecting this fountaining source through that gap. Reverse angle, you can see that gap, lava flowing out through it right there again. And really spectacular, you can see the lava sloshing down here on the edge of the spatter, right? That's how the cone actually builds. So that lava spatter cone has really been growing over the last few days because of that activity from that vent. And we'll look at that a little bit in the time lapse as well. This is a southern vent erupting through the lake as it appeared earlier in the week, and so we'll see if it's still doing that. That may be something that's changing in character there, but certainly something we want to appreciate from the video earlier in the week there. We'll let it run through one more time here. We can catch it the second time around at slightly wider angle. There's the surface of the lake. You see these big coils as the lava is slowing down, and that cool skin on it will start wrinkling and coiling in itself to form those ropey textures. More of a cone building. There's some chunks that might fall off, and here you can get a better view of that southern fountain is shooting up, not nearly as high, but still a few meters through that lava lake. So that's impressive to think that it's coming up through that entire liquid underneath there to erupt even any distance right there above. So we will move on now to the thermal time lapses, and I'll start off just by this most recent last 24 hours from the USGS. We're going to find that this is not going to be enough for us, so we're going to go to the time lapses compiled by Dane and collected by Dane and Bob Martin. from USGS webcams. But we'll start off with this last 24 hours version because it gives us a little bit of a snapshot of what's happening right now. So in the last 24 hours here, it's kind of hard to see, but if I zoom in, and maybe I'll have you start with this, start focusing on this part of the image here. And I'm not moving up and down, but it does actually jerk down when it cycles back through. So what's happening is there's a slow rise of this feature. And in fact, many of these features all these dark features are all rising. And then you see when it loops back to 24 hours ago, you can see the difference of 24 hours on to what it was 24 hours before. So that's really one of the key things here. You see that part rising right there. Let's look over here at the back at these little islets. You can see even this one is exhibiting a new dark band here, right at that margin of the lava, as it seems to be rising out of a liquid. The surface of the lava lake here is still that kind of magenta or darker purple, and you see these flashes of red coming in bigger patches. So this is most likely that crustal overturning, the foundering process we've described a whole bunch of times. Maybe I'll bring up the video from the last eruption during our next broadcast as an illustration. But what you can really see is that this is still liquid lava, but it's not as vigorous, and it's certainly stagnating here in this back half. And this is the big difference to what we saw earlier in eruption, where we saw a liquid surface wrapping all the way around all these features and just churning around everywhere. In fact, it drowned everything that was right all the way across. And just recently, we've seen these features start to rise through the lava lake. First one, then another, and now we're seeing the whole base level that's connecting all these features rising up through it as well. So perhaps this is why I say it's perhaps displacing the lava and essentially sloshing it off to the side there. That's one possibility. So that's a really zoomed in view on the perhaps the dominant process here, which is this filling of the lake is still ongoing. And imagine if that crust is rising, then lava is going to be pushing it from below. So even if you don't see lava at the surface repaving it, it's still filling the crater, and it's still pushing it from below and pushing that thing upwards, the whole mass of it, which is hard to describe how massive that actually is. Dozens and dozens of acres. Right? Altogether, the whole active surface is over 100 acres still today. All right, so that's one set of dominant features. The other thing here, we can see our constant is this new west vent. You can see a fairly consistent glow from here, and an entry point. This little round part right here, that's the entry point of where the lava is going into the lake, and you can see that dispersal pattern as it radiates outwards from there. And these images are every, I want to say 10 minutes or so, so you're not really getting that fine detail of the convection and turning. It's kind of jerky, but you get a little bit of the sense of the motion by the coloration, right? Where you see flow kind of going this way, and it seems like it splits, and you have one part going over here, but another part also going off in this direction. That seems to be what I'm seeing here. And as far as that south vent, you can look at it over here. I'll zoom in as much as I can. It's these sites right through here. Right? It seemed like before it might have been more over here, actually bubbling up. But now it appears like we're having the brightest points come from here and here. So it could be that this thing is coming up through a slightly different spot through this crust underneath here. Remember, we also had an old fissure and vent at the edge of this large island in the southeast edge of it right over here as well. So certainly we know that there was a weakness. The lava was coming out that's somewhere along here, and it could be just not one, but a series of parallel cracks. We'll have to wait and see what emerges one day, or if it's still the same thing that's visible. But it does seem like that is an interesting development, that we're now having an effusion source more through here. And I wonder, it's hard to tell from here, like how much is bubbling up, if it's still bubbling up a few meters in these areas. Certainly possible. We'll keep an eye on that, see what the USGS says. But really from there, you can see that those two sources are wrapping around to the east and then swinging north. And you can see that really it's the further away you get from those smaller vents, the more stagnant you are, compared to the larger vent, which can sustain a larger distance. So we're really partitioning our lava lake into a lot of sectors right now. You got this back sector with these islets rising up and these occasional overturning events, and it seems like almost lapping of the lava coming up into this area over here. And then you also have this gap down here between Old West Vent Island, which has gotten a lot larger. You can see nearly as large as our central island now. And between the two remains a channel that leads to this north edge of the lake. And over here, you can see we're starting to form a rim connecting this old west vent island with a bit more of a levee that's forming. Other bits of that crust are getting pushed upwards right here, right? And it's forming a little bit of a levee, but it has gaps. It's got a gap here and it's got a gap over here, and these gaps are being constantly breached with lava pouring through the gaps here and here, and it seems to flood this ring-like trough in a rim, right? So it goes that way around, it goes this way around, and likewise this way. This way, now I really do feel like John Madden. I'm trying to get through the blocks here. So there's also this big septum that's extended from a large island going towards the north, and this is an important feature that's really separated this whole eastern half from the western half. So none of this hotter material coming from the more voluminous western vent seems to be making it, on a surface at least, to this eastern side because of this division, right? So you can see that all the surface division is essentially gonna allow the lava to go beneath the crust if it's gonna keep filling and filling and filling. That's the 1 day 24 pattern. We can see quite a lot of stuff there. You almost see like a couple layers, right? This is like this west vent island here, and then this levee is almost like an upper layer right through here. And then down here, you almost see a second layer of levee forming, right? So almost like a terrace, like a pancake inside a pancake. So it's really stacked and layered like that. And still, at last report, the lava lake is essentially tilted, right? And it's higher, closer to the vents. So sloping down west to east, as well as from south to north. And so this end being the lowest, and this end over here being the highest. And so that's interesting. Not huge amounts. You're talking maybe 1-2 meters, 3, 6, 7 feet. That's the ballpark of it, but still significant across that entire distance there. Okay, so we may have gotten to the limit of what 24 hours can tell us here. So we're going to turn to our more complete time lapse, and I'll play this from the beginning here to start. From the very beginning of the eruption, the whole sequence. You can see those initial fissures by our central island here. You can see how small Old West Vent Island used to be, and how it's been growing and being pushed upwards, and how there's liquid lava circulating all the way around to this eastern back part of the crater back in here. And you see quite a bit more of the fountaining from the south vent source over here, and you can see that it's certainly slightly more to the east than that other vent by the island that we see here. Right, we were speculating maybe that new source, maybe there's something in here, but you can see early on it's actually offset a little bit more to the east. And there's a couple lines over here and a larger source over here, right? And of course, noting that those initial vents came up right through there. So after that flooding, where we didn't see any of these small islets, you can see these islets start to rise up. So that's the first sign of that crust coming up, or maybe not the first, but the first sign of widespread uplift, and not just this small thing and that small thing. And you can see here these whole areas bulging up as well, there and there. And you can imagine the lava is probably coming underneath and trying to push up as well, right? And so that's the animation in full there. And what I'm going to do here is I'm going to pause it, and I'm going to drag it around like I like to do. I can get it to show here. Hold on. Why are you? Oh, I see. I'm going to have to reload this thing. All right, there we go. All right, so I'll drag it around because I want to show you guys right back here, point out some of these features. Islets missing in the back, and how small this West Vent Island is, right? You can kind of see also that it starts off, I mean, this thing is rising, right? But you can see there's not that big of a gap. It's actually the lava comes around and surrounds it before perhaps lifting it or injecting it or what have you. It's hard to tell what's happening underneath there, right? But it's important to note that this gap is preserved, right? Like, so somehow the lava is able to get through there, even if it's coming around this way, but perhaps also from below, coming below and able to fill that gap. And you imagine that as we have this inverted cylinder, this funnel, kind of like an ice cream cone, if we lift something out of it, there's a bit of a gap on the rims, at least in some of the sides, depending on how you lift it out and its exact shape and all that. But so that's certainly possible to have the idea in play that there could be some of the lava from this deeper part of the lake coming up in these gaps along the perimeter along here as well, not just flowing out from above through those gaps as we just drew. Right, so that's one thing. Let's show you guys how this West Vent Island here is rising up, has risen up over time here. And what you can maybe see is that all the islands seem to rise together. There is one at the end, this one over here, that seems to rise after everything else, so perhaps it's something more of a floater, because once it rises, it starts drifting separately from everything else, as if it's not attached, unlike the others. That's one to watch as I drag it around here. And we can also, let me put it to this side, now we can look a little more closer at this vent here in the south, right? So we really can see that that south vent was more over here in our new location. It really has switched over here in the south, right? A little bit of a change there. You see that kind of disappear here just over the last 36 hours or so. So that's interesting. Certain lava is still coming up through the lake below, and it's still coming out this part over here by the west vent. So if I can zoom it into here, this might work. And then I can actually show you guys how the spatter more recently has really been growing this thing. So there it is. You can really see that vent grow. Let's drag it back and forth here to show you guys how it's really, just in the last few days especially, started to accelerate its growth. The spatter piles up on the backside of the vent there. A nice symmetrical cone forming here in this right view of the image now. Right through there. That's the other thing going on there. And maybe that's enough time on the time lapse for now. We can come back to it and address some of the other issues and get at the questions we might have from there. So, looking at some of the questions here real quick about the will the lava soon drain through? There's no sign of anything draining anywhere. In fact, the lava is still pressurized enough to come out through everything that's piled up on top of here. So at some point, it may reach equilibrium and it may slow down, and that might be what causes it to stop, perhaps. For it to drain away, you really have to have some pathway that's able to take all the lava. And right now, all the flow seems to be coming back towards that summit region. As far as we can tell here. So there's no sign of anything collapsing, and there's still no threat of anything to people. That's probably our first question to answer here. Right, it's all interesting and all cool science, and all of it's just minor stuff, minor details of the changes of the surface of the lava lake, with really no big implication for the consequence of how the eruption is going to change in the future, whether it's going to migrate somewhere else, anything like that. We're just looking at the surface skin changes, because overall, underlying the structurally, there really isn't a whole lot of change there. That's something I can make more clear here. All right, so let's move on from that one time lapse, and I'll bring up the time lapse from the last eruption back in 2020, right? So now I'm looking at, this is January 5th where I'm starting, and this is lava lake was lower. I can kind of take it back, show you guys that whole eruption sequence from the last eruption there. But I want to hone in now just on these last few days of the first week of January here, earlier in the year. Because you see that back then, the lava lake also, it was quite a bit lower, but it also had all these islets in the back, and everything was circulating all around them. And fairly quickly, and it may have to do with the fact that this large island had been drifting, and it drifted and it rotated in position in front of the old west vent, right there. That circulation perhaps disrupted and started the crusting over process in the back half. And that happened just over the course of a couple of days there. Right there, from the 7th to the 8th to the 9th to the 10th right there. And so interesting to note that this is the same process we're seeing now, and you can see that even though they had crustal foundering for a couple of days in that back half still during the last eruption, that fairly quickly the whole thing became fairly solid, and then lava lake retreated to the other parts of the crater while still leaking up around that piston cap along the crater edges right there. Right? That's what happened before, and it's worth bringing this up because in the perspective of these changes of the surface of the lava lake, we're really continuing the last eruption. Really, we just had a little pause of the features changing and being frozen in time for a few months or 4 months. But we've essentially resumed that dynamic nature of the topography of that surface of that pit changing. So interesting to put that together here. 4 months on. Okay, we'll move on from that. We're gonna wrap it up here as far as the analysis, detailed time-lapse analysis with this B1 camera. Also compiled by Dane, mahalo Dane, and Bob Martin is also helping us with the images once again. Mahalo Bob. So this is a view from the east, looking back towards the new west vent is back here. Here's those lines of fissures in the foreground, and the southern vents would be right over here. All right, so there's a before. And you see before, here's all those islets visible in the camera in the foreground. And right away, you see, oh, there it is, right away the lava comes and buries them, except this one tallest one right here, which actually has a bubbling spot next to it as well. Right there. Then you can see a few days in, just that one, and everything is submerged here, liquid lava across the entire surface. And I will play it for you guys, but what you can start to see here is starting back here. See if I can zoom it in. Still have control here. You start to see another little islet emerge. There it is, right there. There's one. Keep it going. And there's another one right there. And we'll keep it going. There's some more, one there, and one there, and one there. There you see stuff rising all the way back over here as well. Advancing it, you see it coming up and 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 up. Here at the end, there is our stray floater that was drifting separately from the rest. But that is our sequence. So I will play it here. You guys see it all the way through. And you can see it's always been circulation back from that west vent coming around this way over here. And the southern vents coming around this way as well. From the beginning, here comes daytime images only, curated by Dane, mahalo Dane. All right, the B1 camera looking from the east to the west back towards the vent. And so it may be that this view in the east may not change as drastically as we've seen here in this first week, because if the lava is no longer going to be moving on the surface, we'll see it tipping and maybe it'll crack and some stuff will come out of there as well, but we won't see it flowing quite the same way if it ends up withdrawing the active surface towards the west there. All right, so that's the B1. How much does it actually come up? We'll look at the lava depths right here. This is the graph for the last week, and the eruption has been going on a bit over a week now, so we don't have the full record. We'll look at that here shortly. And we have an interesting offset here in the middle, but what we can see here is that if we look for the last half a week, since whatever the signal is, we'll talk about that shortly, that we've had a net fairly steady rise with some slowdowns and some speed ups and some slowdowns. We're now currently in one of these slowdowns, and you would expect that it would speed up at some point again if it's holding that same pattern, but we'll just wait and see what happens there. The laser is only measuring 1 point on that surface, so there's lots of points rising at different rates and moving around. So this is just 1 point. It's kind of hard to, you can't really generalize too much from just this one. And that may be what's going on with this spot right here, right? We have heard from the USGS that the final number is actually 258. So the mark of where the line is here is correct. This is where it should be at 258 meters of depth. And so what that means is that this measurement over here prior was artificially high, right? So somewhere in here, we started getting artificially high measurement. Looking at this in bulk now, right? The biggest change is right here, this thing. So you might hypothesize that something rose in the path of the laser right here, right? And that's what that thing is a block profile like that on this graph, where really, if you'd been able to measure that surface, maybe you'd have a plot that was more like this, something like that, right? That might be the true data, might look something like that. So it's still rising, and that's the kind of rate of it, right? So what might have come into the spot here, we'll hop back to our thermal, and we were measuring a spot somewhere around here on this lava lake. And so you can imagine that as this old west vent island is rising, and we were measuring somewhere, I would want to say somewhere in here. You probably can't see that red marker on the red lava, but there, right in there is where somewhere, maybe in there, somewhere in that range in there is where that laser is pointing, in that vicinity. So you can imagine that zone, if I advance it, may have actually become part of the island that rose out of the lava. And if so, then you want to take your laser and point it more over here or something, right? Or maybe more over here. I'm not sure. We'll have to await confirmation if they did move it or what. But that is the working hypothesis right now, is that is what actually happened with that, is that this piece of this island came up and suddenly your data is not telling you exactly what you thought it was. So that can explain that artificial rise from here to here, right? And it preserves that long-term trend of still slow rising and still gaining depth in the lava lake, right? Remember, we expect it to rise at slower and slower rates because it's got a smaller and a larger and larger area to fill. And now, of course, this is being counteracted by the lake retreating and forming perched edges and crusting over some of its segments as well. So this is going to change. We'll have to be on our toes for this here. There's a whole last month from the very beginning where we started off at 226, from 226 up to 258. So that's or 32 meters or so. That's the total gain. And to get the Cliff's Notes version here from Twitter, from USGS, from 24 hours ago, the rise was 31 meters, 102 feet in total, with 2 meters in that previous past 24 hours, for a total lava thickness of 256 meters or 840 feet. I think I saw that question come up earlier, right? That counts the lava from the last eruption and this eruption together, 840 feet. And the lava from the last eruption was still liquid in the core in there, right? So there's liquid lava, maybe you lose 10 or 20 feet or something like that where it cooled against the bottom, if you didn't remelt or erode part of that away by now. So it's really liquid that thick, mostly, right? Mostly 800 feet or so of liquid lava filling that pit, with all this crust stuff floating in it, and maybe more like a slushy than like a completely solid liquid in there, right? All right. So that's our Cliff's Notes, but we do have more detailed information from USGS. Here's today's update, today's daily update, and a few things I'll highlight here. We are at Alert Watch Aviation Code Orange, as we've been since Monday, and everything is still within Hale Ma'u, no danger to people. That's the bottom line. SO2 rates have been going down. We're down to 7,000 tons per day. That's still a lot. It's still a lot, but it's gone down significantly. We'll look at that in a bit here shortly. But you can see here, over the past 24 hours, lava lake rose approximately 1 meter, with a total rise of 32 meters, 105 feet since it began. So there's our number that I just referred to, the 32, 105. Okay. Total thickness, 258 meters, 846, call it 850 feet. And the elevation of the surface has been noted at 775 meters above sea level, 2543 feet above sea levels. Okay. Most vigorous fountains from the west vent. Today they're down to 12 meters, about 40 feet. Yesterday it was still 15 meters, about 50 feet. So, but still 40-50 feet is the ballpark where you're looking at. And that's the sustained ones. And occasionally it's having those bursts where you'll see one that goes poof, slightly higher than the others. The lake's above the base of the vent, and the fountain has built a spider rampart around most of it. Another vent continues to be active in the southern part of the lake, with fountains averaging 1 meter, 3 feet above the lake surface. Still not level, 2 meters higher in the west compared to the north. In the south part, let's see here, areas close to the vent in the western part are 2 meters higher in elevation compared to the north. And the south part of the lake, and 4 meters higher than the east end of the lava lake. So what it's saying is that the west vent is higher than everything. It's tipped up towards the west vent more so than the south now. The west vent being 4 meters something's wrong. There's a typo, right? Because 4 meters is not 7 feet. 2 meters, 7 feet. So somewhere in that range in there. Okay, so crustal foundering still going on. The lake surface is still perched 1 or 2 meters above that ledge, which is 20 meters, 65 feet wide around the perimeter of the lava lake there. They do note here that all smaller islets that became submerged at the beginning of the eruption but have been gradually emerged since then. The central island shows a dark ring marking of cooled lava from partial submersion at the beginning of the eruption, right? And perhaps still because it's still rising out of it as we speak. That's most of it there. There's some more observations, nothing different from the East Rift, nothing different with the hazard analysis. So I will get this text off the screen and show you guys a map. This is the newest map we have from a couple days ago. It's essentially the same area. We have plotted here our islands that are forming, right? Vent sources. So west vent over here, old west vent, I'm sorry, new west vent, old west vent being this island, and our south vent down over here. Right, that's the area. You can see this slightly lighter peach color is that trench on the outside of that levee, right? So really, the lava lake is not active all the way to the edge of the crater. There's a boundary, and this was a boundary 2 days ago, and you can imagine if we were to draw it again, perhaps tomorrow, you'd have a much different boundary that it might go more like that, even, you know, that, and with all this back part crusted over. So we'll wait and see on that. That's just part of the attraction of these maps, though. I like, in particular, these statistics that are put up as well. So 2 days ago, statistics, we can ignore the surface and thickness because we just updated you guys on that. But a fairly close estimate of volume, 3.9 billion gallons, or 14.8 million cubic meters. So coming up on 4 billion gallons, coming up on 15 million cubic meters of volume coming in. I'll compare that in a second to the last eruption. I'm sure that question is there, but active area, 119 acres, 48 hectares. That's compared to the full crater extent, full lava extent, 135 acres. So this is starting to show the retreat of that lake surface from fully filling the whole crater to smaller and smaller areas, which is the same pattern we saw last eruption as well. So speaking of last eruption, to compare it, we'll take this value here, 14.8 million cubic meters is how much has come out so far. And the last eruption, I pulled up this map. The last eruption, we got up to a total of 41 million cubic meters. So that means that we're over a third of the way there to that eruption, right? And altogether, you might say 41 plus the 15, 56 million cubic meters. Altogether total, if you consider this second phase of that earlier activity, right? So on this profile over here, right, where we've come up just really a little bit, but enough to make a difference, right? Something like that. That's where we are right now. Newest eruption. Something along those lines. Like, get it all the way here. All right. Good enough. And of course, the lake, the island rising through the lake, right? So really it's like that as well. Okay. Speaking of the park here, let's come back to this one, right? So there are now, the USGS mentions this, maybe you didn't note it, or I didn't note it explicitly, but lava confined within Halemau'u, but not visible from 2 public overlooks in Hawaii Volcanoes National Park. So everyone, this word has been getting out. We've been trying to tell you as well, but it is visible in a national park. So I put together a short video here showing you guys what the walk to Kīlauea is actually like. I've sped it up, of course, but what it looks like, what the trail looks like going off of the road here towards the caldera. There's Nene around. I saw some Nene fly by. Here coming a Nene. It's fantastic in the morning, right? This is the day we saw a bunch of rainbows as well. If you guys have seen our rainbow photographs and rainbow videos, this is where this comes from. So, but I thought this is worth showing this clip for anyone who's curious about what the walk is on this Kīlauea side, right? Where you can actually get a direct view of the vent. If you can make it past these loose cinders, and this slope right here is the worst one where people have slipped and fallen, and you can see there's loose rocks and there's bushes to avoid. And imagine at night, you really have to have a flashlight to be able to see where you're going at all. But once you get to the edge there is a vent. We'll zoom it way in for you guys and show you some lava close-ups here. And so that's that 40 feet tall. You really can't tell, but 40 feet tall in reverse angle. We can't see that bottom part of it draining into the lake here. It's hidden behind this block. And you really see this splashing and building of the cone that's been evident over the last couple of days. And of course, I want to show you guys a bit of this time lapse of the rainbows marching across that summit caldera. Oh, except that but didn't like it. So here we go. Try again. I decided to start me over. Where's my time lapse? Okay, there's my time lapse. I'll put it back to here. All right, let's get back to the overlook, back down the trail. The old Kīlauea overlook is back over that way. It's not that far actually, but it doesn't have the direct line of sight because of the fissure ramparts are in the way there. So you got to come all the way to the edge here. And then if you have binoculars or a spotting scope or a nice camera, then you can zoom way in and see these views of the 40-foot fountain spattering there, building the cone. You can see that veneer of lava frozen as it's gooping, draining back in to that open vent there. All right, so this is all sped up. It's a time lapse, of course. It shows you the pattern here as all that mist and moisture blows across the crater, and the vents degassing continuously there, and the lava lake filling mostly beneath the crust, mostly not visible as red in the daytime, and that crust is kind of to the right of the vent there. More in here. So, well, it is moving a little bit, but you really don't see a whole lot of action in the daytime. At nighttime, it does glow a little bit more between the cracks, if you do make it out there to see that. So this is a great time, and the lava's come up in the lava stadium to where we can get a direct view of it. So it's visible from there. It's also visible from the north at near Uikahuna, but to the east towards Kilauea overlook by the old navigation station, of course. There is a paved path most of the way there in that case. It might be 1/8 of a mile one way if you can park at the Jagger Museum. And that is an issue that is ongoing now, right? The park is getting very busy, especially around sunset, with hardly any parking anywhere near the overlook. So you have to park 1 or 2 overlooks away, or not be able to get there at all in that time frame, and have to walk a distance to try to get there, and that may not be worth it or possible, depending. So a couple last views of the rainbow here, and I'll show you guys the park PSA. Park PSA here. Show you guys that from Twitter. Do you like spending time stuck in traffic gridlock waiting for a place to park? If so, make sure to visit between 6 p.m. and 9 p.m. So there you go. That's when not to go if you can help it. If you want to be there between 6 and 9 p.m., go early, find a comfortable spot, and just be ready to wait for a while. All right. So that's the word on visitation to the park. And be careful, be aware of others, be respectful, follow their safety guidelines, and all that. All right, so as far as the national park, here's a map of the park. Visitor station, open right in here. The site that I was just showing you guys a video from is down here by Kanakakoi, in this area right in here. So you would have to drive all the way to Devastation Trail and park Devastation Trail parking lot there. Walk out along the old road, and then take the new trail to the new overlook, which is more or less right in here. That's the one. You can see that it is a ways, right? You're talking about 1 mile each way to get there. So even though it's not an overly difficult walk, it is a mile each way, right? And there is a little bit of elevation drop, and you gotta get it back on the way back as well. In comparison, the view in the north from Uikahuna, the former Jagger Museum, is right there. The view site's more or less in here. Right? So if you can get here, this is the closest spot. Otherwise, Kilauea Overlook is within a reasonable distance. You can actually walk there in some distance. If you're forced all the way back to the military camp, that's probably too far to be able to make it, unless you got an early start and have planned accordingly. Right? So that's what's going on as far as overflow parking. And of course, as it fills up here, then you get to park here. And if this fills up, then you're forced to park here. And if this fills up, then you're forced to park back over here, and et cetera, et cetera. As far as down here at Devastation Trail, there's not a whole lot of options, but if you can't park here, then you come back to the Pu'upua'i Overlook and hike the Devastation Trail, an extra half mile to get there, right? Of course, it adds to your walk, adds to the time it takes to get there, so also come early in that situation there. So that's the orientation to the park, and where you can go if you're coming to see the eruption here. So as far as what's going to happen next, we'll turn back to the data. We mentioned the USGS gas updates here, and I'll show you guys the plots at SO2. This is for the whole last year, so in comparison to our December 2020 eruption, you can see here that it took about a week to come down pretty fast, right? And you can see that ours is crashing a little faster, but it's still at a similar level, and we'll always have to wait and see. Our resolution is not that great once we have these extremely high points on the plot, so we can't tell a lot from that necessarily. But we can hone in on the pattern here over the last week and just point out that there's a decreasing pattern, right? We went from 85,000 tons per day to 20,000 tons per day to ranging from 13 to 16 tons per day, and down to in the range of 7 to 9,000 tons per day down here at the far end where we are now. So it's come down substantially, but still that's a huge amount compared to, for example, what any factory is allowed to put out. So there's still SO2 ambient in the air. Let me reload this so I can get our air quality loaded on here, now that we have this in focus. All right, so at present, everything is registering green, but you got to look a little closer. Green at a 50 is a pretty high green there. It's got to be borderline orange, or yellow, I should say. And scroll this right here. So yeah, borderline yellow. And you can see that previously it actually got up into the orange here at 101 ppm. I believe that's the measure. I'm not quite sure there. So still having effects. You can see, even though we have green values, they're still non-zero values or higher than if you wouldn't have an eruption. Not only there, but all the way over here to South Kona as well. So in the green still, but certainly we understand that there's fog in the air there coming around the island. And however, it's not as much within a national park. In a national park, everything is all green, and all the last 24-hour records are all showing green all the way across, all down the board, everywhere you look as well. So all green in the park as well. VOG forecast is similar to before, less amount coming out, so that's great. But still, the dispersal pattern is similar towards Naalehu, Pahala, Ocean View areas especially, but also wrapping around to the South Kona side, and maybe a little bit more up on a hill than down by the water from our reports that we've seen. But really, it could drift actually anywhere out there. So that is the gas conditions here. The gas is related to how much lava is coming out. That's our best proxy for the effusion rate and eruption rate instantaneously there. So when we see the gas going down, that tells us that probably the amount of lava coming out is going down as well. But there's still a lot of it coming out because it's still at fairly high values. That's the bottom line. The other way to try to get at what's going on within the volcano is the ground tilt here. This is the station by that Wikahuna bluff to the northwest, still declining, deflating, as it has been for all the past week since the eruption, doing so. It was doing it at a declining rate early on. It was kind of curving down, but really, if you look at the past week here, it's mostly a straight line. Maybe very, very slightly curved, but it's maybe not slowing down as much as it was before. It still continues to deflate. As far as GPS, contracting across the summit as before. The trends are essentially the same. We don't have to dive into that again today. There's nothing really novel there. We do want to make sure we check in on the tilt at other stations on the volcano. And we see similar patterns around all the summit, with deflationary tilt towards the Halemaʻumaʻu chamber, as well as the intrusion site in the South Caldera that essentially is part of the magma chamber, magma reservoir, since that intrusion occurred so recently as well. Further on down a rift, Changes on the escape road, you can see from the beginning of the eruption as well. You can see there's been some change as well correspondingly. And also at Pu'o'o, 12 miles away, you can see that since the 29th, there's been a deflation on both components there, right? So interesting to note that there appears to be connection all the way there, if that's the case. If we're seeing a response to the rift zone pretty close to when it's happening at the summit, but the response is that the ground is deflating, which means that the pressure is all flowing back towards the summit there, right? Our last tilt station down at Jonica, you can notice, does not show any change whatsoever, no connection at all right now. And that's reassuring for all of our lower east rift zone peeps. Tilt. Earthquakes, we'll finish the data here, and we'll do some questions before we turn to the photos and videos to finish things off, our second part of our update today. Earthquakes are pretty slow still. Here's the last month. Still at fairly low values there. Come up a little bit, but nothing dramatic. There was one large one in Pahala region, which is not related to Kilauea, so we won't really discuss it that much more right now. For the last week, here is that map of where those earthquakes are located. Pahala cluster is still ongoing down here, and you see very little at the summit of the volcano right around there. But you do see continuing, there are still some, but not that many. You see more events continuing on a south flank, as if nothing else was changing or going on, right? So that's normal. That's almost our background still going on at higher rates ever since the 2018 adjustments set things in motion there. So still low earthquake counts, and that's what we have to see here. All right, so we'll just wrap it up this first half here with a couple of views of what else has been steady besides the earthquakes, and that's this west vent here. You can see it's putting out from this S1 camera. There is that lava channel that goes towards the north that spills over through the blocks there and there, and our fusion source down here that seems to be replacing our south vent that's moving off in that direction, and we really don't see any of that eastern section of the lava lake over there at all. So in the future, this one will be more interesting as this is a zone that shows more change. This is not the one today, so we'll just stick with this default 24-hour animation. You still can see that jerkiness of this block. Certainly has been rising from this view as well, if you pay real close attention in there. And the KW camera, this is the same view as the thermal, but with visible light. Of course, you can see that new west vent and that pattern of what it might look like from the ground in that area right there. So those are the cameras, and this is the B1 the last 24 hours, including those blown out night images, right, which now are showing more of this hardened crust with glowing cracks in the foreground here in this front part of the crater, the part that's crusting over. So this is our story. This is our big change, is this crusting over process and everything rising up and through. So that's the first part. That's the summary of it. We'll do more pretty pictures and all that. We'll talk about some of the questions here coming up, and maybe say some thank yous, Dane, when you're ready.
All right. Yeah, definitely. Do want to thank everybody that showed up today. Viewers like you really help keep this content coming. If you like this type of content and want to see more, take the time to like, subscribe, and maybe even share it on your own social media. We also post on HawaiiTracker.com, and you can check out our stuff out there. It's a place where we put it all in chronological order for you, and it gets us a little bit of diversity in terms of the platforms that we use as well. So we do have a couple supporters that I want to shout out. First was we had a super chat from, I believe it was, there it is, Mountain Girl, who says, mahalo for keep everyone updated. I appreciate that support. We also take donations on HawaiiTracker.com/support. We do have a couple supporters, companies that support us. We want to acknowledge them. First one is Kaleo's Bar and Grill in the heart of Pahoa. Definitely a great establishment for locals or for visitors to go and get some good dinner. It's open 7 days a week, indoor, outdoor dining options. They got a full bar there. They got takeout options. So definitely can meet your needs. And they also have a new establishment in Orchid Land that's going to be opening soon. If it hasn't opened already, I need to check on that. Eruption kind of got everything crazy. But yeah, definitely check out Kilauea's Bar and Grill. The second one is Kalani Tours out of Kona. They do a few different types of tours, but one of them is a lava tour, so they will take you up to Halimau and show you around and let you answer your questions and make you a little bit more familiar with the crater, the caldera, and the whole summit region in general. They do more small tours as opposed to the big style tours, so it's personalized for your interests. So yeah, definitely check them out, and we appreciate them as well. We also have the Hawaii Community Foundation support through the Puna Strong grant, and we appreciate all their support as well. So yeah, I think we are ready for some questions.
Yeah, I see you guys have been busy in the chat here talking about the presence of geese in Hawaii. Yes, there are geese in Hawaii. The nene is it? Yeah.
Right.
Our state bird.
Yeah.
It's our state bird. Yeah. It's, they don't migrate. They blown off course a long time ago, and they just made Hawaii their home.
Stayed.
Yeah.
Yeah, they kind of liked it, so they kind of stayed. Definitely, they were once endangered. Now they've been reduced to threatened status.
Yeah. The numbers have been changing. I've heard maybe up to 2,000, maybe 5,000 spread around. Right. There's a big group here in the Big Island, a big group in Kauai as well, and then they're all elsewhere in zoos across the world here and there, in random small numbers too.
We have a $2 super chat from Doug, who says just cool, or with an email, so appreciate that support as well. I did send you a link from Ken Rubin. He just posted some stuff, so we might want to pull that up and talk about it.
Okay.
But let's get into some questions. So the first one, there's a whole bunch of questions, and they're all kind of related to the same topic, and it's about the lava getting out of the crater, right? We know that it's getting close, right? It's still 10 meters or more away, but it's in that range, and it's doing 2 meters a day. The question is where does the Halimau crater end, and where does the caldera floor begin? And it's kind of just a bunch of questions about like, when does it technically escape the crater, and how does that crater, is it still a crater, or is it still Halimau if it were to entirely fill in?
Yeah, it's a good question. It's a hard one to answer, right? As far as the last one first might be the easiest, right? The place name of Halimau, the place that describes has already changed many times over the decades, and you could have asked the same question: do we call a new pit Halimau after the collapse? Do we call the lava lake that came into it in 2008 Halimau, since there was such a long gap in between there, right? So the name itself describing a different landscape is not a problem. That's kind of standard at this place and many places on Kilauea, in fact. So that's easy. As far as where you define the edge of it, that's really where I was trying to find this old USGS map where maybe I think all they did was, here, I'll throw this up on here. It's a map from the last eruption, right? But in this one, they actually put in the contours of 800 meters, 900 meters, and 1,060, or is it 1,000? Yeah, 1,060 meters right there. All right, so the green one is the one that we're getting close to right now. So 800 meters, right? That's the contour. If we get to 800 meters, we'll have a little flow that spills out onto this lower bench right here. That will be that big, right? So the contour below that is 790. Right? So we're getting pretty close to that, and it's right in here that we'll have that first flow. You can see that as lava comes out of that lowest pit, it'll fill in this spot right in here, but it won't really be out of what I would consider a Halimau crater, right? Because you still have this whole area. If you consider this 900 meter elevation, the purple, that maybe is getting closer to me, because you see it wraps around all the way up to here and all the way around. Maybe that might be, that's all still the pit to me, right? And even if you do have a flatter spot here in the north, it's really sloped downwards like this, right? Kind of down like this. It's like a big ramp right here, a big sliver of ground right there. So those are options, right? You might say, okay, 1,080 if it comes into this area that the USGS refers to as the down drop block right here, is this one. Although really, like, that's a down drop block, and that's a down drop block, and this whole thing over here is a down drop block. So they're all down drop blocks. Shout out to Ted Shaneyfeld for talking about that there. But the one that they call the down drop block is this one right here. And so that one is all within a new collapse pit. And you might consider this is your third option of what to call Hale Ma'u. And I'm not sure, I'll wait for someone more expert than me to chime in and, and propose some convention there, right? But we're calling it the innermost pit. And, that the bottom of the innermost pit, the top of the innermost pit, and then the down drop block, that larger pit right in there. And then this larger area we'd call the whole caldera right through there. So that's not going to fill up. We're even just talking about the part that fell in from 2018. We're still less than 10% of the way there as far as volume coming back to fill that thing back in. So that's a long answer to all those filling questions, perhaps, and where's it going to happen and all of that right there, right? And while I'm here, I didn't say this when I was talking about the overlooks, but from this area, this overlook, you can see more or less this part of the crater like that. So that would be a good spot to see that overlook, would be from that north side right in there. Whereas from the Kanakakoa vantage point, what you're looking at is more the vent here to right there. That's kind of what you can see, is that area right down here. Make that a yellow color so you can get a better view. It's more in there. You don't see as much of this other side. So this side, you can see the fountain, the vent, and on this side, you can see where it might actually spill over. That's the difference there, right? And the park doesn't want everyone to go to the same place all at the same time because there's nowhere to park. Everyone hopefully got that, right?
All right. So the next question is also kind of about the terminology. Is it still considered, Theresa asked, is it still considered a vent, or would it be considered a cinder cone now, that western one above the lava lake level? And she mentioned seeing that last night from the overlook.
Yeah, so it's both, right? I mean, the vent is a place where the lava is exiting the ground, and because it's falling around that vent and building a feature of cool bits of lava that we call a cinder, and it's forming a cone. The vent is within the cinder cone, so it's kind of considered all the same thing, right? This vent is a cinder cone. You could have, for example, a fissure on a side of a slope where it can't pile up and it just flows down and away, and then you wouldn't have a cinder cone. It would be more of just a non-cinder cone kind of vent. So saying cinder cone, you're getting more specific about the morphology, the shape of the thing, rather than just saying it's a place where lava is coming out of the ground with no further information from that.
All right. Stephen asks, the southern vent, where is the pressure to make it fountain coming from? The floor of the volcano or some random gas release area?
It's, I think, the fissure the area that was a gas vent on that southern edge of that crater is where the fissure opened, and the fissure goes underneath that lava, and it's coming up through the lava. That's the best answer I can give. And, there might be some more solid structure down there that's helping it funnel upwards through whatever's down there. But that's just a consideration, right? There's really no way to know what's going on down there.
All right. So the next question is Kenny asks, is the lava draining from the north half of the lake, revealing the crust or the slab of the surface?
I mean, I think it's draining it, but the key point to notice is that even as it's draining, that whole surface is rising. So that's really it. It's draining because the thing is being lifted up and it's being in place underneath it rather than on top of it. So yeah, it's tricky, and that's why I'm avoiding to use the word draining, because that implies like it's going away, and really it's not. It's just piling up in a different order, right? So rather than having lava and then solid, we're having lava and solid in a different order, but it's still coming in.
Right. Rex asks, is that crack above the new west vent pushing steam the probable top of the current fissure there? Is that like the point that you would draw the line to?
So I think it's connected because it's been degassing consistently. Yeah, a good observation, noticing that. But the original crack, when we saw the eruption begin, there was actually along the crater wall, almost on contour. There was like an upper one, and then there was an offset to the north, a slightly lower one along contour as well. And so I think it's just like a crack in a rock that's fairly local, and I think it does connect though, allowing the gas to escape through there for sure.
All right. Well, I think I can handle the rest of the questions that I see in chat, and we will get one more round going at the end of the program.
All right, mahalo Dane for collecting and curating all those, and mahalo you guys for interacting and passing your questions and helping us educate each other about the wonders of these amazing natural features that can sometimes be dangerous to our communities, and we want to address, we want to address both the beauty of it, but also make sure that we're talking about what's going on so that people understand when there's a reason for concern and when there's not a reason for concern, such as now, there's no reason for concern from this volcano. It's a great time to go and visit and to see it, in fact. All right, so let me put up here what Dan suggested we show you first, which is Ken Rubin's tweet of frothy and glassy fragments erupted at Kīlauea volcano. They flew up from that vent up onto the crater rim to be collected above there. No one's going into the crater to collect these samples, they're just waiting for what flies out at them. And so here are the samples, and they're going to do some studies on them there. So that's awesome to see that is going on. For those of you guys who are wondering about sample collection, that is how a sample collection is done. Right, when you have a giant hole and stuff's blowing out anyways, there's no need to repel in there or anything like that. All right, so this is a little compilation of the 3 videos USGS put out from October 2nd, so it's a little bit dated. It was back to last weekend, so the activities, we've discussed how it's all changed in the last few days here. But still, we want to see the videos that USGS puts out, so here's a video of the west vent as it was on October 2nd, seen from above when it was fountaining a bit higher still, and you can see the fountains shooting much higher than we saw in those later videos that we saw more recently. But still building that spatter cone. Maybe you can notice that there's not as much of it over here in this area. And it's more along this backside through here. Hard to tell. This now is a southern vent, erupting through the edge of the lake. You really, from that southern crater rim, you can't quite see the edge of it down here. But you can see the great telephoto here of how much gas is escaping, right? And all eruptions really, once you get to that near surface, the gas is bubbling out of the lava, and once it bubbles out, it starts to rise, and as it rises, it expands, and it keeps going higher and higher, and it's like opening a can of soda or pop or champagne, or that same analogy that we've looked that we used before, right? And then that's what propels all the lava out. Here's our central island vent, right? The edge of the vent. It's shooting out from the side here. You see the original fissure was more along this side, but clearly another segment over here. And I should scroll it over so you can see that there's upper vent actually coughing out chunks of lava up here as well. So this connects like a little chimney going through there, right? That might be a similar situation as a crack we just saw by a new west vent, something like that, right? Facing the opposite way, of course, but that could potentially, depending how the lava comes up and how the gas is exiting that crack, it might start entraining pieces of lava as well and start collecting the run event is a possibility there. So those are the 3 videos from the USGS. Let me play this again here at the end when we do some questions, but we'll move on for now and start going through the video chronology. Go back to October 5th, which was Tuesday, and look at some of the USGS photographs here. Viewing from the west, similar as a Kilauea camera view here, west vent, and a very clear strong flow indicators coming out, and very clearly still having a south vent at that point in time a few days ago. Right, so keep going here. Western vent, once again, fountain. There is that exit pattern of the skin of the flow in a lava lake, coiling and forming what are typically seen on the hoi hoi flows, the hoi hoi coils. There. And here, a HVO geologist using a laser rangefinder to measure the elevation of the active lava lake. There, another view of that west vent here. Maybe I'll open this one separate so I can zoom into it, because I want to show you guys a little closer. Too close. A little closer, this exit point of the lava out here, right? So you can see a few days ago there's still a decent slope here, right? But maybe because it's building up a higher septum up here or something, right? So it can pond slightly higher even as the lake level is rising to the base of this vent right through here. And so maybe that's what's going on. You can still see this overflow channel coming down through here. Very, very tiny dribble coming off this direction. It's cool to see in this photograph as well. Right there. That is really what I want to show you guys, is that exit point. Scan it around. All right, let's come back. Okay, this is showing us an overflow, so let's look at the overflow. Filling the trench, right? So we have this boundary, the edge of the perched pond right through here, and this overflow doesn't seem to be coming from this photograph. It's coming from somewhere off down here and flowing up, and it's flowing within this trench between the levee and the crater wall. And I've already reminded us that during the last eruption we had lava actually squeezing up from below through the cracks in areas like this. And as this whole solid piston is rising, it forms a gap against the wall, and you may potentially have that flow from below as well as this overflow pattern from above going on. It's interesting there in the trenches. Another view of the west vent. Lots of great new west vent photographs coming through. This is interesting, some tremor plot, and so explain what's going on here. This big image here with this black signal, that's what they call the Webby quarter. That's basically just measuring the tremor of the volcano. So when these are bigger earthquakes going on here, these fatter, like something that looks like that, right? But what they've done is they've highlighted this yellow area right here. And instead of showing it just as a single black line, we're going to break it out from a single black line into all its components. And that's what this right here is. This is all the components of that yellow section right in there. And so the way that components look is like a dark line like this when you have a decent sized earthquake. So this is an earthquake that's registering across the entire spectrum. And they kind of tail off. There's a pattern you often see there. But over here on this right side of this, you see there are still some earthquakes, but a lot less of them. And instead we have this persistent harmonic tremor through very low frequency bands in particular. So that's the kind of tool that USGS will use internally as they analyze tremor and the different spectra of energy that are being released by the earthquakes. Okay, so along with the update, those are the 3 videos we just showed you guys. Come from this October 5th update, dating back to the 2nd. And we'll advance to October 6th. Another fantastic new west vent shot here. You see that amazingly beautiful radiating pattern of lava spiraling out from that entry point right here. This is that area that's churning, right, and that skin is forming, and as it spreads apart, it stretches, and there are gaps that are filled by lava that rises from below. Right? This zigzag structure you see here, breaking across the crust. Right, the whole thing is just stretching out like a taffy, getting pulled apart. And those gaps in between are getting filled by the lava from below. And that combined with this coiling of the skin, right, the skin forming, and then getting rolled over and over and over to form those coils or ropes that are arcuate, like in the direction of the flow. Cool stuff there. All right, we'll keep going. Did I show you all those photographs, or did I skip some here? That was West Bend. We showed you guys this movie, and there is also, yeah, I did want to show you guys this. This is the something we've seen before. This F1 animation But just to show you guys, USGS is also keeping an eye on this and is also coming to similar conclusions. This is going through, this is the most of the whole eruption, but it only goes through yesterday. So that's why we used ours. Ours gave us a whole extra day of analysis there. But similar results. They can say that, let's see, let me scan down here in our caption. And they note the features, where the features are, like we just showed with you guys by actually drawing on a screen. And here, they say, the northern surface of the lava lake appears to be in a process of stagnating and forming a thicker crust due to the distance from active vents. The slow crustal growth is similar to what was seen in the last summit eruption. So that's another way of saying what we showed you guys earlier by actually showing you guys the last eruption time-lapse as well. Okay, a couple more here. HVO geologist making observations over the lava lake. Another view of that lava lake similar to that KW camera there. Oh, now it's getting pretty dark outside, so we'll load up the webcams fresh before we sign off here. Give you guys a nighttime view of it. But October 7th, photochronology. Here is some of that crystal foundering or overturning process going on, right? And this is just one still shot of that whole process that goes on. And I wonder if I could find the foundering video somewhere around here. I'm not sure if where exactly I have it. Oh, I think I might have it over here. The foundering. I'm gonna call an audible here and bring up this foundering video if I can find it. Show you guys here what that process actually looks like from the last eruption. You understand what I'm talking about for some of our newer viewers here. So there's a foundering. This is sped up in time, but you see that old crust being consumed by lava rising from below, and the whole thing kind of overturns over time. And it looks, on a time lapse, looks like it flashes all the way across there. Dane, you got something for me?
No, I was just gonna send you the link to it.
All right, mahalo. There is a little bit of crustal foundering. That's one of the videos of the foundering process there. There may be some others that we've shown before as well, but let's see. Yeah, there's that second part of it as well too. So all right, we'll leave it at that for today, and go back to the photographs. There's an exit point from that new west vent into the lake right there. Those same features we see before. And we also have a before and after from just before the eruption began to, what's the date here? The morning of October 7th. It's after 6 a.m. this morning. So before and after. Not quite the same lighting. It's a little bit hard to compare the level of it, but at least visually you can see the difference. That, what are we at now? 9 days, 10 days makes. Okay. So that is all the photographs we have from USGS. So I want to make sure, let's refresh our webcams here and get our sunset views. Here's our S1 camera at sunset. It's still active. It's a new west, still active here in the south from what should we call this? New south? I don't know. We're starting to get confusing. Here's our B1 vent showing our B1 camera, mostly stagnant, hardened, textured eastern crater, and only these areas are looking like active lava flows at this point in time. There and there and there. And there as well, right? And actually, you know, let me zoom in because I notice this perspective. Maybe let's zoom into this. As much zoom as you can. Enhance, enhance, enhance. It's super blurry, and you can see here, it looks like there is those exit points from this new south. 1, 2, 3 here. It's almost like a crack, right? Like there's a solidified crust here, and there's a crack you can see, and it's pouring out the crack from these sides over here. Interesting. We have to await closer telephoto images from the USGS of that location in particular. Okay, so that was our B1. KW right now, perhaps the prettiest one. Sunset view here when it gets it just right. You very easily see what's red and what is not. So you can see from yesterday to today, the area that has red lava on the surface is much, much less. Certainly so from the last update we had at the beginning of the week. KW. Cover the bases here, nothing else going on the surface, but we can look at the towers. There's a tower, the gas coming out. Here comes our thermal camera. Thermal camera is showing still an entry point. Oh, a dark spot right here. That's interesting. Is this piece of cone gonna fall off? Maybe it's gonna breach there. It's kind of hard to tell what's going on, but it's a little bright on this side. Like this is getting hotter. It might, I don't know. Interesting coloration pattern there. Doesn't look quite stable to me, but that is the F1 camera. And I expect, as we scroll down to the Mauna Loa strip road camera, not quite dark enough yet, but there is that lava lake area and the gas plume blowing downwind, likely light up the sky all across there. Those are the webcams. Today is Thursday, so giving them as much time as possible. We can see that the Volcano Watch is finally published for this week from the USGS. Published just within the last hour and a half since we've been on the air here. And let's see what they talk about. Oh, they're going to talk about what I've been talking about here for a while, which is reminiscent of pre-1924 activity. Ephemeral lava fountains, craggy spires, and drifty islands. So now they're reflecting on those observations, compare them to recent activity. So yeah, talking about Old West Island here coming up there and there. And all right, so I'll since we're coming to the end here, and you guys who are still with us are likely super interested, I'll read some of this a little bit here, huh? September 29th is on the left, and October 4th is on the right here. So, all right, I'll scan it a little bit here. A broad, high light brown to tan feature made up of less dense material appeared to be floating in a lava lake during the last eruption. Over the next week, it migrated around a lake based on flow directions from vents active at the time, eventually halting in the center of the lake. Geologists found this feature to be reminiscent of the floating islands described by Kilauea summit observers a century ago and earlier. As eruption waned in intensity, more of these features formed in a variety of sizes and heights. All became stationary eventually. So contemporary geologists suggest that raft may be a better term to describe these features, which we continue to learn about with a new eruption at Kilauea summit. All right, so the new eruption begins. By the time the geologists arrived, only the largest island, a small island to the northeast, and a part of the high-standing west vent from 2020 remained above the surface of the lava by the time they arrived, because it burst out really quickly at the beginning there, yeah? Several hours later, the northeast island was submerged by lava, and the highest point of the large central island was only 10 meters above the surface of the new lake. It seemed apparent that the newly forming lava lake was going to continue rising and eventually cover all remnant topography of early eruption. However, as eruption progressed, the height of the large island above the lava lake surface started to increase, and islands that geologists saw being submerged in lava soon also started to reappear. The smaller island in the northeast part of the lava lake was submerged at 5:20 p.m., reappeared a little over an hour later. For the next few days, they all reemerged. So this is all, for you guys who've been watching this is all we've been telling you guys for, this is the third update now. It's unclear why they have reappeared. The recently cooled crust seems buoyant in a way that is allowing it to gradually float up within the new molten lava erupted within the past week. It seems unlikely that these are individual pieces of crust detaching from the old solidified lava lake and rising up. If that were the case, at least some of the smaller islands would then migrate around the lake as lava flows moving around push them around. So they're all stationary except for floating vertically upward. Most likely that they're all large chunks of the older lava floor lake moving upward together. Similar views were observed by Thomas Jagger about a century ago. However, Halemaumau crater was much smaller than about 1/5 or 20% of its current size. Detailed documentation allows for these observations, made decades apart, to be compared. So that is basically that. Yeah. In the end, they agree that it's very interesting to consider these features that are transient in the context of what happened back 100 years ago, as we've been doing for a while now, huh, Dane? That was part of our focus while we were waiting for in-between eruptions to happen, huh?
Yeah, definitely. It's interesting, though, the whole The one thing that got me about both these eruptions was the intrusions that happened. What was it? Just a few weeks or a month beforehand.
Mm-hmm.
That was interesting just to see, like, oh, by the way, you have a warning that something's coming on these ones.
Yeah, that happened. Yeah.
It happened to work. All right, you ready for some questions then?
Yeah, that's basically it. Yeah, I mean, I just want to remind everybody that, Hawaii Tracker, we do have, if you guys are watching on YouTube, we do have a Facebook group, and there are a lot of other photographs I'm not going to show you guys from other contributors. Here's on my lands page. There's art as well. There's more than just volcano stuff, but go check that out if you like. And you can also, for example, see images of the rainbows and stuff there, and on hawaiitracker.com.
Yeah. Always new stuff on the Hawaii Tracker Facebook group. Try and get some news out there as well. But yeah, let's get into some questions then.
Yeah, sounds good.
A longer one from Jennifer. I'll just go through it. Talking about the magnitude 4.6 in Pahala that happened a couple days ago. It was the strongest that she's ever felt. Definitely stronger during the last 6 months, in her opinion. But what could this increase in? She asked, what about the increase in strength? There been any study on the Pahala quakes and the activity as they're connected to Kilauea and Mauna Loa?
It's the strength of earthquakes is a very, very tricky thing, because it's all about how the energy disperses through the ground and the exact path that it takes to get from where it came from to wherever you happen to be standing, or wherever you are to experience it, right? So that can change a lot depending on where you are, right? So imagine if you're, the ground underneath you is more spongy, or if it's more solid, it'll shake differently. So that's one part of it. And unless the earthquake is exactly of the same, what we call earthquake family, the same exact vibration pattern from the same exact location, then it's really hard to compare that, right? So as far as why there's bigger earthquakes in general down there, that's an interesting trend that we haven't seen as many earthquakes that are as large as this in the Pahala region. But if I recall, I want to say in June we had a 4.0 as well that was widely felt from Pahala. So very, very similar in that case. That was also fairly recently. It's not something that's historically very common, although there have been earthquakes there a lot, but not all very big and felt. So it does seem like there's like a whole magma surge going on in that whole Pahala region through the hot spot deep underground, feeding the volcanoes, feeding Kilauea. It may have fed that whole activity in Mauna Loa earlier this year, and Mauna Loa now is back in neutral, but it may have been enough to feed Mauna Loa and Kilauea, and it's still feeding Kilauea and causing all this to happen with Kilauea, perhaps, long term, big picture style, right? Because remember, it's 30 miles underground and 30 miles offset laterally as well. So it takes a while, and it takes some distance to cover to actually make it from that area to anywhere near the surface, right? So if you're in Pahala region, you can feel the earthquakes, but I wouldn't worry about them coming up through the ground, straight up through there, right? We have seen earthquakes both deep and shallow, but with a big gap in between. And so when you see earthquakes shallow, it's not just that there are shallow earthquakes, period. It's more about are they progressing from deeper to shallower in a pattern continuously through the whole depth, not just something moved down here and something moved up here in response, right? It's almost like if it's just adjusting. It's like banging in a ceiling or banging in a floor kind of thing. They can work separately. Yeah.
Right. This question I liked. Kenny asked, could the piston, as you call it, drain and all the lava goes under it, and yet the piston keeps rising? Think of like a water under a frozen lake, yet the ice is still rising. No holes for the water to go through.
Yeah, absolutely. I mean, that's mostly what our last eruption was doing, right? If I maybe can pull it back here, I have it up back here in one of these tabs somewhere. Yeah, this one right here. So I'll drag it through the end, right? But you can see after that back crust formed, it all still keeps rising for the next 4 months or so, right? That whole back part of the lava lake. So even in our last eruption, as a crust formed, it was still coming up underneath it and pushing it upwards, and that's still going on, and that's why I say it very, very similar in that regards, and almost a continuation of what we saw before.
Yeah, definitely. This is a question I've seen a couple times. We haven't really done it anytime recently, so we'll end with this one. Could this eruption fill the entire caldera? And I've seen that one multiple times today.
Well, so I won't say a straight out no, but if it does, it'll be the eruption that ends all eruptions for all time in Hawaii, because that's a huge, huge, huge space, and that's highly, 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 highly unlikely. Yeah, there's so much space. You fill the innermost pit first to the bottom part of its spillover. You fill it to the top part of its spillover. You fill that inner collapse pit. Now you can go on the caldera floor. You start filling the caldera a little bit. You still end up spilling out of the caldera to the south as well, and you can't fill it all the way up. So, there's topography, there is volume, there is a pattern of eruptions in the past, right? We haven't, maybe if you go back to the 1800s, maybe there's an eruption that filled that much area with that much volume that quickly. But I don't know if we have volumes. We can say okay areas, but it's I think it would be unprecedented as far as what we know right now. Not to say it can't happen, right? There are always extremes. Definitely. It does happen someday. That's why I won't say an absolute hard no. But if it does, that'll be rather than the whatever one every 100 years collapse, we're going to see the one every 1,000 years eruption. That kind of thing it would take.
Right. Vegas would bet against it, basically. There's an interesting observation, or somebody caught a comment here that I want to share. It says from USGS Volcanoes, they're talking about the laser finder that was measuring the lake. They went out on the 4th and re-aimed the laser pointing at the lake surface instead of that floating vent blob.
Awesome. So that was my working theory, and it's confirmed.
Yep, pretty much.
So science.
All right, well, yeah, there we go. All right, well, that will do it for questions. If we didn't get to your question, we apologize. We are going to be premiering another episode of Drones On. This one's going to be covering June 30th through July 6th of the 2018 eruption. Talk about some of the marine life die-off and some of the changes that are taking place in the lava channel by Green Mountain. So that'll premiere immediately after this live stream, so check it out. It's only about 10 minutes long, this one.
Right on. And I do have like a scheduling note to throw in here. I'm not sure that I'll be able to do a live stream on Monday because I will be hosting family on island here. Try to do it again on Thursday next week, and maybe we can add in a second one, possibly on Tuesday, possibly on Sunday, if it's warranted. But I may have to just wait a full week into the next one unless there's something major going on there. And as usual, we'll try to post these shorter videos in between to help keep you guys informed of what's going on, as well as the text updates, etc., etc. So, Dane, you got any input as far as scheduling there?
We will just, if anything happens, we will come back and do something live. We'll try and keep those videos up for sure, kind of as Phil was saying there. But as of right now, there's not a whole lot taking place inside the crater, so it's easy enough to go back to once a week if we need to.
Yeah, right on. Yeah, there's lots of pretty images and videos, and if anything, I just encourage you, if you're able to this is a great time to visit the national park. Be outside and see the wonder of nature, and yeah, it's that was a little reflection here, right? There's been lava in the caldera in 2018, 2008, right? But you could see it bubbling and overflowing a bit, right? But lava fountain in the caldera, it's been a while. Right? We didn't really see lava fountains in the crater in 2008 to 18 at all. The previous one before that was 1982. It happened twice in 82. I want to say that they were both one-day eruptions. So in 82, there were 2 single days of fountain viewing at Kilauea caldera in 1982. Prior to that, what was it? 1974? A few days in 74, there was fountains. The point is, you guys, it's pretty rare to have fountains visible within Hawaii Volcanoes National Park for this long, and I hope it lasts a long time. But every day you get is bonus as far as I'm concerned from this point out, because it's not typical that you can see these things, right? So now is a great time to if this is your thing, now's the time to see it. Yeah, I'll end it with that. And if you're dying for more information or more volcano stuff, and maybe figure out how to go and see it with your own eyes. All right, so with that said, I hope you guys appreciate enjoyed all the volcano. I know you appreciate it. You guys are telling us all that, and you guys are supporting us with your likes, shares, and subscriptions. Mahalo, keep doing that. Do that some more. Go and share us on other volcano information sources, right? Wherever you guys are seeing other people talk about volcanoes, you can please go and share our feeds there as well, and that'll help us keep it going there. Yeah. All right. So as Dane said, don't forget Drones On coming up right after this, as soon as we can get it lined up to premiere. And unless something else happens in the meantime, we'll see you guys next week. For Dane DuPont, I'm Philip Ong. Aloha, everyone.